Hi, this is an overview of the DMTF, recorded December 2021. My name is Jeff Hillen. I'm a distinguished technologist with Hewlett-Packard Enterprise, and I currently serve as the DMTF president. So DMTF is an industry standards organization led by innovative industry-leading companies. We've got a global presence with membership all around the world. What we really do is support diverse and emerging and traditional IT infrastructures through manageability, whether that's cloud, virtualization, network server storage, power cooling. If it's got management, we work on the manageability standards either directly or with an alliance partner organization. Our standards are nationally and internationally certified through ANSI and ISO, and that enables a more integrated and cost-effective approach to management. We have the ability to simultaneously develop open source and our open standards, and that particular emphasis that we do in some of our standards helps create not only the support and tools, but also the standard and code itself. The DMTF board is really a who's who of manageability infrastructure, as well as our membership in general. We've got 3 levels of membership, and we're really proud that these companies have stepped up to provide the care and feeding of the organization, and we really appreciate everything they do for us. Again, the DMTF is an international standards leader. We continue to grow our global presence through ISO JTC1 SC38 representation, and that relationship with ISO as a pass submitter allows us to take our standards directly to ISO and fast track them through, and then they go through ANSI. The DMTF is an open and collaborative industry standards organization, either through our membership in general, which is open to everybody, or through our open source development efforts once they're published. We've also got the specifications themselves that are published, and anybody can provide feedback on those specifications and submit feedback through the feedback portal. A lot of our standards go through a work in progress phase where we'll publish the standard out there for feedback either through our alliance partners or for folks that aren't necessarily a member of the DMTF. And then our standards get adopted by a number of open source projects. Lately, OpenBMC and OpenRMC and ODM and libSPDM and some of those efforts have taken on the DMTF standards, but we've got a rich history of open source projects adopting DMTF standards. We've grown our alliance partnerships over the last few years. It wasn't something we did purposefully. It was more of a collaborative effort in the industry where everybody's looking at each other's standards and saying, well, let's not do this twice. Instead, let's make our standards work together in a very tight-knit method. So we've developed relationships with a number of industry standards bodies. Some of these are more mature, like SNIA. We've been working with them for, gosh, well over a decade, probably nearly 2. Some of these relationships are maybe a little less than a decade old. Groups like the Open Compute Project, which have really embraced the manageability aspects of our standards in their specifications, and it's worked. That relationship is working really well. And then some of our newer alliances like CXL, which is coming out, and HD-Base-T, which grew into a relationship because of security protocol and data model. But the rest of these organizations are folks we work closely with in developing our standards, because there's no point in having competing standards. Instead, you want these standards to work very closely together and make sure that one is a source for the other's information, or you don't overlap each other's standards and leave the industry confused within development of or support of the standards as a whole. We've also got an academic alliance program that is global. Here's a list of the universities where there are members who are actually participating and looking at our standards, doing research on them. Some of these people are doing code development. So it's a program that we really appreciate, because these people reach out to us. We don't really reach out to them, and to do either research or investigation in these areas in which we do standards. We took a number of efforts to become more efficient and agile a few years ago, and that has really helped us, particularly in the latest situation. We've got the support and tools and infrastructure for efficient cost development and collaboration of our open standards and our open source code. The ability to do those simultaneously, and all of the support of the organizations that go with it. The management of the websites we have, the management of the open source, the producing of documents, the the messaging aspects and components of that, and showing up to events, and all of the infrastructure that it takes to get a standards organization running and going, the legal documents and framework and the IP policies. We've got all that done, and we continue to improve it as the community changes, because standards development changes. Our ability to do open source is something that we did over a decade ago. And so, having that, as well as, the virtual events and virtual meetings and all of the administrative support and other resources necessary to operate and promote the standards, is something that the DMTF is well established. We've been around for over 2 decades. So we were formed in 1992, in fact. So it's getting close to 3. And really, we were chartered to create open manageability standards spanning diverse and emerging, as well as traditional IT infrastructures. And that includes cloud, virtualization, network servers, and storage. We evolved from desktop management. That's where we got our start with DMI in 94, and then DEN in 97. And in 98, things started to get more distributed and open with WebM and SIM and all of those standards. And then the alerting standards format in 2001, and the common diagnostics model in 2005. OVF was a particularly interesting one with in 2008, the open virtualization format. It's kind of the MP3 of virtualization definitions. vMan followed after that, and then we got into WSMan and the whole of Smash and Dash initiatives. From there, we grew into the CMDBF and CADF, and lately it's been Redfish and SPDM. And of course, this doesn't even go into the MCTP and PLDM efforts that we started well over a decade ago. I guess getting close to 15 years ago. So what happens where in the DMTF? Right now we've got 5 major groups. These are the work groups and forums. These aren't necessarily the parent committee's executive and technical committee that oversees some of the work. For participation, the work really happens in PMCI, SPDM, Redfish, SMBIOS, and SIM. And PMCI is the place where, if you hear about MCTP and the binding specs, if you hear about a CXL binding, an I2C binding, or a PCI binding, that's the place where that happens. If you hear about RDE or firmware update, monitoring and control, that's the work group where all that happens. The Security Task Force is the subgroup of PMCI where SPDM takes place, and that's the standard on authentication, attestation, and key exchange for the industry. And Redfish Forum is where Redfish is defined, and Redfish is in every server shipped, and is expanding its scope rapidly. And I'll go into detail of these first 3 in just a second. SMBIOS is one of those standards you may have never heard of. It's really been in every x86 machine shipped for over a decade. It is the ubiquitous standard for how the machine conveys information to either the hypervisor or the operating system on how the machine is laid out, what things are there. And so that structure enables the machine to get going. And then SIM, including Smash and Dash and the Common Information Model and WebM and WSMan, and all of that is done in the SIM forum. So the PMCI working group is where platform management, communication, and infrastructure, all of the standards inside the box are developed. We had to change the name because the definition of exactly what a box was became harder to define. But it really is the suite of standards that provides that inside the box communication and infrastructure where we exchange manageability information between the different components, whether that's a management controller to a management controller, think, enclosure manager to a BMC, or network controller to a BMC, or maybe not even a BMC. There could be some other communication control point of manageability information inside the box between all the different devices, whether those be network devices, management devices, sensors, smart NICs, it could be a host interface. All of these are defined in the PMCI working group. While it was initially formed in 2005, the initial standards were released in 2007, and these were a suite of specs that all work together. And so I'll show you a layer diagram of that in a second, of how MCTP and PLDM and NCSI and all of these things fit together. But that really is the suite of specs where sensor and firmware update and the data extracted from the device that is surfaced through the BMC through standards like Redfish or a web GUI. That's where all this information is gathered and how manageability is done inside the infrastructure. And so there are ways of transmitting this traffic over all of the buses that are inside of the platform, whether those are PCI or CXL or I2C, I3C, USB, KCS. We've got mappings to MCTP for all of those, and then PLDM maps on top of MCTP. So there's over a decade of implementations within servers and desktops that, and these technologies and interfaces are really complementary, and they enable the DMTF external facing data models and remote management protocols, things like Redfish and Smash and Dash. The architectural diagram of a platform management subsystem is something that the PMCI architecture uses to figure out what devices we're talking to and what the layers we're talking to over these specific devices, because there is a communication channel from the centralized management controller to the different devices in the system. And so the management controller to management controller information can be conveyed over certain protocols, but the platform software could, communicate either serial or KCS or potentially even a network device. So there's all those host interfaces up on the top. Eventually, you're going to leave the management controller and get out to the network consoles, whether those are Redfish or SIM or even a remote management console. And then you have to talk to all the managed devices, whether those are network controllers or other managed devices. Those are all those southbound interfaces on this particular architectural diagram. And you can see the different protocols that are used to talk to that. The way we layer PMCI is down at the bottom, there's the physical topology, whether that's RBT or PCI VDM or SM bus, I2C, I3C, serial, or even KCS, and some of these are host interfaces that you see over on the right. But there's all mappings from MCTP to those different physical layers. And then MCTP itself is the packet format definition that gets transported over those physical topologies. And then we've got bindings for how they fit into MCTP, the different upper level protocols, whether that's NCSI, which can either go over RBT or MCTP, or it's monitoring and control, which is a type 0 and then there's all the PLDM types, because PLDM can go over MCTP. And so there's a whole bunch of things mapped in PLDM that you see in the orange box. But there's also NCSI and Ethernet pass-through and NVMe, as well as SPDM, that get transported directly over MCTP. And then MCTP type 6, which is secured message, is a way to encapsulate in a secured method, and we'll go over that in the SPDM docs in just a second, where we can take all the MCTP traffic and thus PLDM traffic and securely wrap it and encode it and encapsulate it over MCTP. And so you can make sure management traffic in flight is secured. And then in the orange box is everything that can go over PLDM, monitoring and control, and SM BIOS, and FRU data, and BIOS control, firmware update, and then of course Redfish device enablement. So all of the information for Redfish can be garnered from inside the infrastructure, and all the rest of this can be gathered and communicated inside the infrastructure to do things securely or unsecurely, depending on your platform requirements, through the different mechanisms defined by the PMCI working group. Here in 2021, we've got a number of current specifications in progress. There's an update to NCSI. We've got some accelerator modeling going on in a white paper. A PLDM file transfer is going on, so there's a way to get debug and large log information to and from devices to the management controller. The security protocol and data model specification 1.2 is coming out very soon. We're working on test tools for PMCI, which is the first time we've done that for something this low a level. PLDM for firmware update is getting an update, and then we're working with CXL on MCTP bindings. And there's also an MCTP 2.0 that this work group is working on. So if you have interest in seeing what the 2.0 definition for that is, or you have feedback, there's an overview of that. It's still early on, and you can take a look at that and find that on the PMCI work group page or the standard publication page from the DMTF. The second thing I'd like to talk about today is the security protocol and data model that's being done within the PMCI working group by the Security Task Force. Really, you've got to have security for everything inside the infrastructure. There's a whole lot of companies out there talking about root of trust, and so they've got some kind of trust mechanism inside the box. But how does that root of trust get expanded to the rest of the quote-unquote platform? You do that through component security, and that is the foundation for a zero trust model for everything inside the platform. There's a number of potential attack vectors. Here's a few on the screen, but really any component is a potential attack vector inside the infrastructure. And so what we needed is, since the PMCI working group is communicating with every device inside of the infrastructure, let's figure out how to do that securely and figure out how do we trust the different components inside of the system. And that's really what SPDM does. It enables component security. So what is component security? It's cryptographically verifying the identity, firmware, and configuration of every component within inside that chassis or domain of control or whatever, sheet metal, whatever you define. And that's what SPDM 1.0 did. And then we extended that to enable authenticated key exchange. So you can exchange the keys in order to encrypt the data and integrity protect all of the communication between the components. And that was what was done in SPDM 1.1. And then also we were able to encrypt and integrity protect the management traffic over MCTP. And I showed you that on that layer diagram. And so that enabled higher layers to build on the secure foundation to provide a demonstrably trustworthy infrastructure for customer workloads. So when the system boots, the root of trust can take over, verify its little area, make sure it's trustworthy, and then extend that root of trust through SPDM and authenticate, identify, verify the firmware and configuration of every component, and extend the root of trust to the entire platform. SPDM 1.0 had two really big major features, and that was authentication and attestation. So I can authenticate that device, I can make sure it is who it says it is. The same way that TLS verifies that you're talking to your bank is how we verify that we're talking to a valid component. So it eliminates a lot of the worries about supply chain. And then attestation, we can measure the mutable and immutable code inside of any device that supports that, as well as potentially configuration components. Again, it goes down to what's supported by that component. But if it supports the SPDM protocol and data model, you can go and do these two major features. And then we did it in such a layered way so that it could be referenced by other platforms and other standards. So we're working with various alliance partners on mapping to their standards. And you can see those people here. There's also other adopters that are working on mapping to SPDM as well. And until we get alliance partner engagements, we don't put them on this slide. So SPDM 1.0 authentication allows the platform to identify the attached component and enables it to determine exactly what to do if the identification of that component didn't verify correctly. We don't tell you what to do, but we enable it. And then it allows the platform to verify the state of every component. Cryptographically, we leverage X509 v3 certificates. And then we've worked between the PMCI working group and the Redfish forum to extend that identification outside of Redfish. So an external security manager can go in and poke around and look and see what components were validated and which ones weren't. So the session key exchange was a thing added in 1.1. So here in a very high level diagram, you can see between the requester and the responder, which is what we would call the root of trust and the managed device. Show me your identity. Here's my identity. Here's my cert, my signature. I can verify that I am who I say I am. Okay, great. Now show me all your measurements. Okay, I'm running this, I'm running that. I've configured this. Here's a big, secured hash over the whole thing, and I can guarantee it's fresh so that it's not, subject to various attacks. Great. Okay, and then in 1.1 we added the key exchange, which is, kind of how SSL works, which is okay. Great. Now that you say you are who you say you are, and I know that you're running the code I think you are, let's get some keys so that we aren't subject to various attacks inside the infrastructure. So if anybody's snooping or trying to tamper inside the infrastructure, you can go ahead and cryptographically verify that every packet being exchanged from here on out is protected. And we do that through session keys. And that's what's in 1.1. So one more thing I'd like to talk about is Redfish and what they're doing. Of course, what is Redfish? It's the industry standard software defined management API for converged hybrid IT. Initially based on HTTPS and JSON schema. It was roughly based on OData v4. Schema backed to be human readable so that we could be equally usable by apps, GUIs, scripts, humans, where you could just poke at it with Postman or something and be able to read it. Extensible, secure, and interoperable, and that extensibility, as well as the separation of protocol from payload, from data, really allowed Redfish to be extended to all kinds of components in the infrastructure. So while the initial release in 2015 was focused on servers as a replacement for IPMI over LAN, it really was capable of things that IPMI over LAN never was, and that includes rack mount, but bladed infrastructures, future requirements, and then extending that scope to storage, network attached storage, what we did with SNIA, and that's what they called Swordfish, but also DSIM, working with AshRay and the rest to cover facilities and power and cooling and buildings and crack units, and then working with ITF and other organizations like Gen Z and CXL to cover fabrics, and then telco people to cover some of the Ethernet switching as well. So the scope really has grown since Redfish's inception. And here's the timeline you can see where we really did all of that, where 2014 we were first formed, in 2015 the first models came out, but in 2016 we quickly added BIOS and disk and memory storage, volume fabrics, switches, PCIe support, a new host interface in 2016, compatibility in 2017, LDAP, AD, Open API, telemetry, and scheduling in 2018. In 2019, we did aggregation and Ethernet fabrics. And then in 2020, Gen Z and NVMe OF standards were incorporated. DSIM really started in there. And then in 2021, we added Smart NICs, manifest-driven composability, licensing, power distribution, and a whole lot more as the years are going on. So we're working with a whole bunch of other industry standard partners, some of them more closely than others. Certainly we're very close with SNIA and NVMe doing Swordfish and NVMe, and we're working with other standards like CXL and Gen Z to get our fabric model right. And that's a lot of our latest work, as well as the DSIM work. So that's really where our focus is, particularly now, but that's always changing based on what our members require and what our alliance partners want to see us put out. So there's a whole bunch of white papers and other artifacts. DSP 266 is the main Redfish spec. I'm particularly a fan of the schema guide, DSP 2046, because it's a human readable definition of everything that's in all of the CSDL and JSON schema and Open API docs. You can go in there and figure things out much easier than trying to parse through any of the schema bundles. But if you are doing coding, well, then you'll definitely need to use the schema bundles or the open source tools that turn those schema bundles help you turn them into headers for C and things like that. So there's a bunch of open source that goes along with this, as well as presentations and white papers that are out there to provide education on Redfish. The Redfish Resource Map, again, this is the 1.0 version of Redfish, the very initial release. The way we broke things up helped us extend Redfish later on and add new, I call them sandboxes for people. So, we started out with, okay, we've got systems, but that's kind of the data plane, right? All the logical view of my system, where these are the resources I can get to over the data plane, right? My processors transfer data to and from memory and disks and NICs and all of that kind of thing. Whereas the chassis was really the physical view, which is what did I bend my sheet metal around, and what are the layers of sheet metal or PCB, right? I could have a card, and that's one physical chassis, but I could have a piece of sheet metal like a rack mount server, and that's another chassis, or I could have a rack, and that's a chassis around a chassis. So all the contains and contained by relationships of chassis within chassis was something we did right up front. But power and thermal are really the power domains of the chassis, the thermal domains of the chassis. You're running physical lines there, and those are kind of different than the logical view of systems. So we broke those out, and that's different from the management view. I might have one manager managing multiple systems, or I could have a one-to-one relationship, or I could have a separate manager for my chassis. My enclosure manager on a bladed system is different, and so we had that managed by relationship between the managers and the chassis and computer systems. So you you could tell who's managing what, which computer system is in which chassis. And that initial infrastructure that we built, that initial resource map, really gave the industry a set of building blocks that they could then add fabrics to, add a storage service to, add other, composability services to. So you see those services kind of hung off the service route, where, I've got tasks because maybe my job is long-lived, or I've got a session with my service. I need to keep track of who's logged in, as well as which accounts those are. And then there's eventing, because something happened and you need to subscribe to an event so you can find out that somebody unplugged a NIC, or you've got a thermal condition. Registries we use there's a couple of different kinds of registries, but one of them is message registries, so that you can figure out what messages can come out of this particular system. And then my schema files can be included with an implementation, so you don't have to go hunt for them on the internet. One of the things Redfish focused on initially was out-of-band management, but they also realized we needed to replace the in-band management so that all of the information that it used to get, as it expanded, it could be extensible too. So IPMI KCS was a very bitwise oriented PIO, single byte at a time kind of interface. And we needed to, have something more robust that could do, megabytes or larger at a time. And so what we did was we basically exposed a NIC, because all of your code written for outside of the manageability interface is built on a network. And so you're doing RESTful HTTPS packets with JSON payloads to and from the BMC. Well, why not just expose a NIC already? And it turned out this was really easy and cheap to do for all the existing BMCs, particularly ones that had, like, say, a USB controller where you could just do a emulated USB NIC, surface it to the host OS, just like you would surface any other virtual device, and voila, now you've got a BMC available, and you can use that same code in your host OS to get information to and from the BMC. So the same user accounts potentially. We realized that it needed to be a special kernel mode account, and so the spec accommodates that. And but really, it means you can also run that same kind of code. And so we're encouraging the OS vendors to be consuming the Redfish data instead of IPMI data, and use that method to access things to and from. It isn't a perfect fit. It doesn't work for everyone. PMCI working group is working on another bitwise host interface for those low-level things. But for high-level data that are using existing security accounts, this works pretty well. Another thing Redfish did was interoperability profiles. There's a large amount of Redfish that is optional, and so what they wanted to do was take some of that optional stuff and provide a way for either customers or end users like OCP to provide profiles and say, look, if you build an enterprise class database server or a pizza box server that's, a 2-socket server with 4 DIMM slots, this is the way it must look. And so the interoperability profiles, they're a machine readable definition, but they're also human readable, and there's a way to generate human readable documents out of them. And these same documents can then be used to run the conformance test suite, which is a bunch of open source tools that can test the conformance to this profile. So that really enabled the authoring of profiles not only by the DMTF, but also partner organizations and others to validate a Redfish implementation. There's a few open source efforts around Redfish. You can go to redfish.dmtf.org and link to them, but you can go to dmtf.github as well and find the open source projects. But we're not the only ones doing them. There's other folks like OCP that have efforts like OpenBMC, OpenRMC, and the Device Manager. The Linux Foundation is working on ODEM right now. We did do some vertical integrations as part of Redfish for OpenStack, Ansible, and Puppet, and you can find those out there. So it all depends what you want. If you want some of those conformance tools or small client tools that'll just reboot a server or just update a firmware, the client tools in the tackle box. If you want to write your own code, the client tools in the tackle box can help you figure out how to write your own code. There's a bunch of companies out there that have their own open source tools, and then SNIA has the Swordfish tools that also work with Redfish. And so most of those are applicable as well. We've also got, the last thing about Redfish is the developer hub. When in doubt and you're looking for more information, go to redfish.dmtf.org. There's the schema index. All the files out there for the schema are published out there. The specs, links to the GitHub tools, the registries, other documentation. There's also mockups hosted out there if you want to see what your payloads could look like. There's a whole bunch of mockups out there that you can kind of peruse and get the feel for how Redfish works, whether it's a simple rack-mounted server or how a bladed server might look, or how fabrics might look, or storage, or what's a JBOD look like. You can go out there and see what these systems could look like to help you start writing code. And there's a whole education section and community as well. There's the Redfish user forum that's curated by Redfish Forum Weekly. So you can go out to the user forum, post questions, whether you're an implementer or an end user, and have them answered by the Redfish experts in the community. And then, of course, you can get to the YouTube videos and the webinars and the white papers and presentations as well. One last thing I'd like to leave you with is really the benefit of standards. Something all of these standards that the DMTF and other standards organizations have in common is they create a common framework from which to innovate. It really creates an ecosystem of interoperability that increases customer awareness, drives market adoption. We have that whole messaging arm that makes both customers and the implementers aware. It really does reduce your development costs. DMTF is a very affordable standards organization. And if you look at the education of participating alone that you get, there's a whole bunch of things you wouldn't necessarily have thought about as you're working through the architecture with industry experts. And so for much cheaper than an individual it would be on your payroll, you can get a lot of this work and leverage it on your own, as well as be part of an ecosystem developing the standard. And then there's, of course, the government support, right? A lot of government entities want you to support ISO and ANSI standards. And if you want to have your product available in governmental organizations, those that require those support for those standards, you might as well just participate and help develop those standards. And then, of course, you get the visibility. You saw the companies that I talked about earlier. You get that kind of visibility if you participate. And the different levels get more visibility or less visibility based on where you are in the organization. And then, of course, there's benefits for customers, right? You can get, by requiring standards for your purchasing, you're going to achieve interoperability and portability of anything you're customizing for that individual platform. You can keep it much more generic, and that allows you to have vendor choice. And so you can choose your products based either on vendor and feature innovation or best practice solutions where, all vendors bring ideas to the table. And again, it reduces your cost through increased ecosystem and interoperability from the various providers that you can purchase from. So that's the state of the DMTF here in December of 2021. As always, if you want to stay updated, subscribe to the newsletter, go visit dmtf.org. And if you want to become a member, which I would encourage, is go ahead and go to the dmtf.org/join page. So thank you for your time, and I hope you found this information worthwhile.